Hello, students. In this video, we will talk about hypothesis testing. In any research or in any research that involves questions like, is there a significant difference or any cause and effect relationship, you need to test your ideas. And you test your ideas using statistical methods. Therefore, when you test your ideas, it's imperative that we know the different types of hypotheses so that we can do testing of such ideas. So when we talk of hypotheses, a hypothesis is actually a prediction about the relationship between two or more variables that you have. When you try to formulate your hypothesis, it's actually a translation, the actual translation of your quantitative research question into a precise prediction of your expected outcomes. It's like you're proposing a solution or an answer to your research question. I emphasize that hypothesis is meant for quantitative research in this case or in our discussion because in qualitative discussions, we do not develop hypotheses because we find our ideas, we find our prediction in the responses that we get from our participants. So therefore, when we talk of hypotheses in this video, we actually pertain to the hypothesis for quantitative research questions. Okay? Hypotheses can be developed inductively. When we say hypotheses are developed inductively, we get our data from observations. We get our data from related literature. We develop our hypothesis based on what we read and based on what we know and what we have assessed beforehand or before we do our study. When we talk of deductive hypothesis development, we develop our hypothesis based on an established theory. It's actually testing your theories, okay, and apply it into your own study. So that's why it's called deductive. Okay, you develop a hypothesis from a generally well-known fact and apply it to your specific situation, which is your study. Now, to say that our hypothesis is testable, okay, we should make it or we should state it that reflects, in a way that reflects our expected relationships between our independent variable or the presumed cause or the antecedent and the dependent variable or the presumed effect or the outcome within a population. Now, there are several types of hypotheses, and hypotheses are classified according to different forms. Now, the first type that we will discuss is the hypothesis that's classified according to complexity. Now, when we talk of hypotheses based on their complexity, it can be either simple hypothesis or a complex hypothesis. Now, we say that a hypothesis is simple if it expresses an expected relationship between one independent variable, and one dependent variable, right? So the key word here is one-to-one, all right? One independent variable and one dependent variable. For example, on this side, you can see that this is a simple hypothesis, all right? Because there's only one independent variable, which is the warm solution for body cavity irrigation during surgical procedures, which is signified by your X or your independent variable, okay? And another variable will be your independent variable, which talks about about maintaining a higher core body temperature. So as you can see in this example, this is a simple hypothesis. Okay, so it can be because it has one independent variable and one dependent variable. When we talk of a complex hypothesis, this is a prediction of relationship between two or more independent variables or two or more dependent variables. Now, if you state this variable with two independent variables, or you state this hypothesis with two independent variables, that already makes it a complex hypothesis. Likewise, if you add another dependent variable in this particular example, okay, that will already make it a complex hypothesis. Another type of classification or classifying your hypothesis is through the use of according to their relationship. All right. Hypothesis can be associative hypothesis if it states that there is a relationship between the variables. Okay, between the variables. Like for the example on this part. Okay, there is a direct relationship between decisional involvement and work quality. In this particular statement, the word direct relationship signifies or connotes an associative hypothesis because you're stating here that there's a relationship between your independent variable and your dependent variable. However, in associative hypothesis, you're only looking on the influence and not the direct causality. Because if your hypothesis emphasizes causality or a cause and effect relationship, that becomes causal hypothesis. Because it suggests that there is a cause and effect relationship that exists between your variable. So if the statement is directly saying to you that one causes the other, then definitely that is considered as a causal hypothesis, like for this example. Another type of classifying or another way of classifying your hypothesis is the use of classifying them according to directional and non-directional hypotheses. When we say directional hypothesis, this pertains to the one that specifies not only the existence of relationship, but also tell you the expected direction of the relationship between your variables. If you read this example, all right, the key term that will tell you that this is a directional hypothesis is the presence of direction or words that denote direction, like a positive or negative. Okay, when we encounter the word direct relationship, that's already a directional hypothesis. When we say there's an indirect relationship, we mean that the relationship between the variables are inverse. Okay, when you say inverse, if one variable goes up, the other variable goes down and vice versa. And that denotes also direction of the relationship. So therefore, if you encounter any words that denote direction, or leaning to any side, that's already considered a directional hypothesis. Okay. In contrast, non-directional hypothesis does not stipulate the direction of the relationship. If we state this as a non-directional hypothesis, we state it as there is a relationship between direct coaching to academic motivation among students. So we remove any direction words that may indicate where our relationship is going or where our prediction is going. No? Some people would argue that using non-directional hypotheses is better because it eliminates bias, it eliminates our presumptions when we try to find a relationship between our variables. But in doing research, and if you did your research properly, and if you do your literature review correctly and adequately, a directional hypothesis is a reflection of your is a reflection of what you have known about your topic. Okay, so it's highly encouraged that we focus our hypothesis into a directional hypothesis. Okay, because this reflects our ability to synthesize what we have read in our literature review. And moreover, when we do statistical testing, we get more accurate results when we do or when we use directional hypotheses because we entail a one-tailed test for this type of hypothesis because we're looking only on one side. Okay, later on, we will differentiate when do we use the one-tailed and two-tailed test. Okay. Now, hypotheses can also be classified according to their function. Okay. Well, if according to function, the hypothesis can be identified as either a research hypothesis or a null or statistical hypothesis. Okay. Now, when we talk of research hypothesis, this is the statement of your expected relationship between variables. Technically, when you are doing research, your hypothesis should always be stated as a research hypothesis. By the way, when we say research hypothesis, this is also known as your scientific hypothesis, right? So your research hypothesis is the reflection, no? It's the reflection of your literature review. It's the reflection of how you apply your theoretical framework. It's a reflection of how you see your variables based on what you have read and analyzed in your literature review. So it's highly recommended that we use research hypotheses when we talk of or when we develop our research proposals and write our research papers. On the other hand, when we do our statistics, we always use the statistical hypothesis or a statement of negation or a statement of equality. Because in null hypothesis, you are stating that there is no relationship, no difference between the independent and your dependent variables. So let's look for this particular example. If we say that there is a direct relationship between decisional involvement and work quality of employees, okay, we are saying that this is a research hypothesis because you're stating that there's a relationship, you're predicting that there's a relationship between these two variables, and that you are looking into its direction. But if you state it as there is no direct relationship, all right, you are actually stating a null hypothesis or a statistical hypothesis. No? So if by function, null hypothesis is used for statistical testing or for statistical purposes because this is the one that we support or do not support when our statistical results are out or once we arrive with our statistical results. according to the function, it's meant to be used for statistical testing only. Okay. Now, once you have your statistical results, and once you have your statistical results, okay, and you treated your data, no, statistically to test your hypothesis, you will now be doing, no, you will now be doing a decision, no, deciding whether to accept or not accept or not support your hypothesis. Okay. So to decide whether your hypothesis is accepted or not, no, we establish our level of significance. So the level of significance is usually set, or the alpha is usually set at 0.05. For studies which require stricter conditions, no, stricter chance, no, of committing errors, no, we want a lesser chance of errors. We use an alpha of 0.01, no, or even an alpha of 0.001. So whichever you choose, okay, whichever you choose, okay, that will determine whether your results are statistically significant or not significant. When we say our results are statistically significant, it means that the obtained results are not likely to be because of chance, or were not obtained because of chance at some point of level of probability. Now, all statistical tests yield, no, a computed value. Now, if that computed value is greater than the tabular value, then you can say that your results are statistically significant. If you use a statistical software to compute for statistical significance, there's a value there that you need to look into, which is your probability value. If you're using SPSS, you usually look at the sig value, okay, or the significance value. So it's also the same as your p-value. Now, if your p-value is less than the desired level of significance, which is your alpha, 0.05, we say that your results are statistically significant. Now, when we say your significance are not, or your results are not significant, okay, it means that any observed differences or relationships could have been the result of chance fluctuation only. Okay, so if your p-value or the sig value that you get from SPSS is greater than the desired level of significance, then your results are not significant. Okay, and if your computed value is less than the tabular value, then we say that your results are not significant and may be brought only by chance fluctuation. So, why do we need to establish the level of significance? Because it's one way to prevent errors, no? Or your type 1 error. Okay? So a type 1 error means that you reject the null hypothesis when it's actually true. So it means that you're concluding that the results are statistically significant when in reality, they just came by pure chance only. Okay? So the risk of committing this error is determined by your alpha, or the significance level that you choose. So that's the value that you set at the beginning of your study to assess the statistical probability of obtaining your results, or the p-value. So as I had mentioned earlier, if your p-value tests lower than the significance level, it means your results are significant, okay, and consistent with your research or alternative hypothesis. Okay, and if your p-value is higher than the significance level, then your results are considered statistically non-significant. Now, on the other hand, when we talk of type 2 error, this means that you reject the null hypothesis when it's actually, or when you you accept, no, the null hypothesis when it's actually false. So this is not quite that not quite the first case. Okay, so it looks like something like this. Okay, it looks like something like this, like the type 1 error or the false positive, no, saying that a male person is pregnant. Okay, and type 2 error is a false negative one wherein you're saying that you're not pregnant to a pregnant woman. So to help us understand what type 1 and type 2 error is, we look at this table. All right. So type 1 error is false positive, no, which is signified by probability that is set, no, at 0.05, 0.01, 0.001. Okay. Now, we do not commit type 1 error and arrive at a correct decision if we reject, no, okay, if we reject, no, a true null hypothesis. All right. And the same goes for the type 2 error. Now, deciding for the one or two-tailed test values will be always based on the directional or the direction of your hypothesis. If your hypothesis is directional, we use a one-tailed test. When we say our hypothesis is non-directional, we use a two-tailed test. That ends my lecture for this particular video. And if you have any questions, you can always send me a message. Thank you very much and have a nice day.